Hey guys, Mr. B here again, bringing you another awesome math video. This one is the first of my calculus series that I'll be recording, and hopefully it'll probably be about 20 or 30 videos, and with a little tiny book accompanying it for some calculus review for my students, CPT. Calculus placement test that they'll be doing for acceptance to university, and this is the first one on one of the first topics that we did this year, which was limits of rational functions. So when you're doing the limit of a rational function, first of all, you want to think about whether or not this is what's called indeterminate form. So I'll write that out because my English not the best. Indeterminate form, and my students know that my spelling is my greatest weakness. Indeterminate form. So basically what that means is when I sub -1 into this guy, I'm going to get 0 over 0. And that's actually what I do get. If I sub it in, so I'd have, this would be 2 plus -3 plus 1, that'd be 0. And then -1 plus 1, 0 over 0. So this is indeterminate form. So basically what that means is we just do not know what the limit of this guy is without doing something else. So with rational functions, that something else is factoring. So you need to be able to factor for the most part. Now I've got another video coming where you can sort of get around that. But at the beginning of a calculus course, you need to be able to factor in order to do these limits. So if you look at this guy, this is a trinomial, and some people might call it a complex trinomial because you have this 2 in front. So in the past, in order to factor this, you've probably done decomposition. Well, I'm going to do another way that I call Barnes method. So Barnes method is a little bit of a cheat method, and it has its ups and downs. And I have another video on this that you can watch. I'll put it in the links, man, in the comments, and that you can go to it and see. Some people might know this as Joe's method, but no one knows who Joe is, so I took his method. So basically it starts off the same as decomposition. You have to multiply these two, so it's what? Adds to give you 3 and multiplies to give you the last in the first one, which is 2. So the numbers that do that are 2 and 1. So the part that's a little bit different than decomposition is that we take this number that's in front of the x squared, and then we divide both of these numbers by 2. So when you have that, now we reduce down any fractions. I should also say that Barnes method, you have to make sure that there's no common factors here. So there's no 3's or 2's or numbers or x's or anything that we could take out first before we do it. So in this case there's none, so we don't have to worry about it. So once we reduce down these fractions, any fractions we could have to be reduced, like 2 over 2 is 1. If this was 2 over 4, we'd have to reduce to 1/2, but it's not, so we don't. So now we just write it out as x plus 1, and then x plus 1 over 2, a lot like if you were just typically factoring. Now the next step is we don't want fractions in this little step right here, so what we do is we basically multiply this bracket by whatever the denominator is, 2. So my students just think of it as, I bring the 2 up, put it in front. But really I'm multiplying this fraction alone by 2, so I get x plus 1, 2x plus 1. And there's my factored trinomial. So what I'll do now is I'll go back to my limit. Don't forget we're doing a limit video. And I'll go ahead and I'll take the limit of this guy. So I have x plus 1 over 2x plus 1. So I factored it now. And then I'm left with x plus 1. And some people might be saying, why do you have to do this piece? Well, some calculus teachers are probably going to want you to put that there just to show you that you understand, it's indeterminate form. So once we get to this step, then we're thinking, well, can I cancel anything? And luckily enough, I can. So that essentially is taking out the 0 over 0 part out of my expression, so out of my limit. So if you look here, this is actually, -1 plus 1 is 0, and then -1 plus 1 is 0. So that's what we're doing. We're getting rid of that piece that's 0 over 0 and removing it. That's why sometimes you might hear it called a removable discontinuity. Now what we do, since we have only 2x plus 1 left, we can actually evaluate our limit. And then what I say to my students is the limit is like you have one bullet in a gun. Once you use it, it's gone. So once I use that -1 to sub in, it's over. I can no longer write it down. I have to simply get rid of it, and it's gone forever. Forever. 2 times -1, that's -2, plus 1, and that is -1. So the limit of this rational function, 2x squared plus 3x plus 1 over x plus 1, is -1. Not too shabby. So that's a fairly straightforward one. Probably, if I was guessing, you wouldn't get something that easy on a calculus test, even though it's not really that easy. But once you get into this stuff, it will be, guys, to be honest with you. All right, let's try another one that's slightly harder. So let's try this guy. So the limit as x goes to 3, let's see, x cubed plus x squared minus 9x minus 9 over x minus 3. So it's very similar to this this last one. The only difference being is now I have a cubic. So the question comes up is, how do I factor a cubic? Well, you've probably heard of integral zero theorem or rational roots theorem, but there are other ways, and one of them for this type that works particularly well is called grouping. So grouping, what we do for a cubic is we recognize that things, when you group up a cubic into its first two and its last two pairs, sometimes they are factorable. So you kind of have to have, you know, I don't know what you call it, you know, when you have premonition vision, I don't know what the word is, you can see into the future if this thing is going to factor correctly. So if I look at this and just do a mental factoring, if I take an x squared out of this, I'll be left with x plus 1. If I take a -9 out of this, I'll be left with x plus 1. So when we factor each pair, we want to be left with the same one, the bracket. So it's kind of, it works in a select few cases. Your teacher's probably going to give you one that will use it, because otherwise you don't want to be using rational roots theorem or integral zero theorem on a calculus test. I wouldn't do that to my students, because to me that's kind of useless. Plus there are other ways to get around it. If you watch one of my other videos, I'll show you by far the best way to do the limit of something like this would be using L'Hopital's rule. So first of all, this is 0 over 0. I just did the mental math for you. And then I'll take out a -9 out of this first one. Actually, before I do that, let me just do this. This is what grouping is. This is why they call it grouping. Because you can group up the first two and the last two terms into two separate brackets, just like you do with decomposition. And that's probably why they push decomposition a lot, is for you guys to be good at grouping. And yeah, so now we can factor, that's a cubed, x squared outside, x plus 1, and then plus -9 outside, x plus 1. So if you look what I have, I take out a common factor of x plus 1. That's the way you should think of it. So if I take out x plus 1, I'm left with x squared in front of the first one and then -9. A lot of people just think, well, I got the same in the both brackets, I'll take that one and then take what's in front. So that's what, you know, most people think about it. And then we do difference of squares on this guy right here. So x squared minus 9, so it's x plus 1, x minus 3, x plus 3, just like that. So now all you got to do is you got to go ahead and replace this guy up here. So the limit as x goes to 3, x plus 1, x minus 3, x plus 3, all over x minus 3. And then you're hoping something cancels by the magic of television. The x minus 3's cancels. And there you go. There's your 0 over 0 part again. So 3 minus 3, 0. 3 minus 3, 0. Gonzo. So now I can use up my silver bullet and go ahead and put it right into the limit. So if you look at what I'm left with here, I'm left with 3 plus 1. So there's my 3 plus 1. And then I'm left with my 3 plus 3. And that gives me 4 times 6, which is 24. And there it is. Another limit video, or another limit example done. Let's do one more. I'm on a roll. Let's give it a shot. Let's see. Let's make this one slightly harder. I'll do another example with. All right. So I had a little camera malfunction there. So this is the last example that we're going to do. So I'm going to do a similar example to that one. Just make it a little bit more complicated. You know, increase the difficulty level, or not by a whole lot. So let's see. x cubed plus 5x squared minus 4x minus 20 all over x squared plus 7x plus 10. So guys, how you do these questions is kind of up to you, but I like to do any complicated factoring. I like to just chuck it to the side, not to convolute my limit. So again, this is a grouping example, so I can group up the first two and the last two terms. I always separate them with a plus sign, even if my first term is negative, always. So I'll take an x squared out of this one, I'll be left with x plus 5. Take a negative 4 out of this one, I'm left with x plus 5. Then I have difference of squares again, so x plus 5, x squared minus 4, so x plus 5, x minus 2, x plus 2. So there's my cubic factored. So now what I have to do is come back over here and start working on my limit. So the limit as x goes to negative 2, sub that guy right back in there. Let's see how's it going. Now we're hoping to be able to factor this bottom guy. I should mention 0 over 0, can't forget that. So let's see, that's x plus, adds to give me 7, multiplies to give me 10. So 5 and 2 would work. So 5 plus 2, 7. 5 times 2, 10. Here we go. And we get really lucky this time. Bunch of stuff cancels. So I'm taking out, 0 over 0 here. This one's kind of irrelevant, but it still cancels, so we can make it work. But this one is the 0 over 0. And then I go ahead, sub in my number. So I have negative 2 minus 2, and that is negative 4. Alright guys, I should say, and gals, I hope this really helps, and if you got any questions, feel free to drop me an email or drop me a note, or I'm on Twitter too. I got like 10 followers, so go ahead and follow me on Twitter. You can be number 11. Alright guys, thanks for watching. I'll see you guys in class.